Okay, so continuing with the constant velocity particle model, we're now going to be learning how to draw both position versus time and velocity versus time graphs. We're still talking about constant velocity though, so that's important to remember. If you want more discussion of what constant velocity means, you might want to watch the video on motion diagrams, the first one of this series. But basically, constant velocity just means that how fast you're going isn't changing. You're also not changing which direction you're going. Um, Another thing to define from the very beginning is that we're going to be using this variable x to mean position throughout this video. That's where you are, and we are measuring position in m. M stands for meters. We'll also be using v as a variable to stand for velocity, and we'll be measuring velocity in meters per second. So let's just jump right in. The first kind of graph we're going to be drawing is a x versus t graph. Remember, that means position versus time. So you're going to be drawing position on the y-axis. Now that's a little weird. Notice that means we need to label our y-axis x, because x stands for position. So position in meters, and then we'll also be labeling the x-axis t for time in seconds. Now, when we draw these graphs, remember that the rule is the object is moving at constant velocity. That means it's going to cover the same position or the same distance every second. So if I were to put some labels on this, right, the first thing to realize would be that at time of 0 seconds, the object is going to be at its starting position. Now let's say it starts on the negative side. Okay, so that would mean that you have a negative starting position. Okay, negative starting position doesn't really imply anything except that if you think about your motion diagram from before, hopefully you're comfortable with motion diagrams. We said that you always pick an origin, and on one side of that is positive position, on the other side is negative position. So if you have a negative starting position, that just implies that your object starts somewhere on the negative side of the axis. And it can start anywhere really, that's kind of up to you. But if I put it over here, that means it's starting on the negative side of the origin. And then let's say it's moving toward the positive side. So it's getting closer and closer to the origin. It passes the origin and continues in the positive direction. We'll draw in arrows to show the velocity. And then we want to transfer that onto this graph. Well, like we said, 1 second later, it's going to be closer to the origin. So I'm going to draw the dot for 1 second, not at the origin, but closer to it. Notice the origin is represented right here. This is 0 meters of position right there. The next second, it's actually reached the origin. So for time 2, this represents 2 seconds. I'm going to place it at a position of 0 meters. So this is 0 meters and 2 seconds. For the next second, represented right here, it's now past the origin. It's over there. And for the next second, it's going to be over there. So notice that it is moving in the x direction, which indicates the change in time, 1 second at a time. And then it's also moving in the y direction, and the y direction represents position. So the change in position is going to be the same every time. The other way that we can say that is, we say that this line is going to have constant slope. So whenever we draw a position versus time graph for constant velocity, it's going to have a constant slope all the time. And what that slope indicates to us is how fast the object's going. The steeper the slope, the greater the velocity. The less slope, the lower the velocity. If it's a positive slope, that means we're moving in the positive direction, like this example right here. If it was a negative slope, that would indicate that we're moving in the negative direction. So we're going the other way, like the example I'm drawing right now. So this would be a negative slope. If the slope's 0, your line's just perfectly horizontal, that means you're not moving at all. Okay, so the two things we want to pay attention to on every position versus time graph is the starting position, what we also call the y-intercept, and the slope, because the slope tells us the velocity. Okay, take a second, pause it, look at these three lines, and think about what is different between these three different graphs. Okay, so hopefully you did that. You're going to notice, first of all, let's look at the slope. The slope is the same for all of these. They all have equal steepness. And since slope means velocity, we can also say that the velocity is the same for all of these. They all have positive velocity because they have positive slope, and it's the same amount of velocity. The difference is that they have different y-intercepts. Okay, so this one has a positive y-intercept, this one has 0 for a y-intercept, this one has a negative y-intercept. And the y-intercept tells us the starting position. So that means the starting position for all of these is going to be different. This one starts on the positive side of the origin. This one starts at the origin, and this one starts at the negative side of the origin. But they're all moving at the same velocity. Moving on to this next one, pause it again, look at these position versus time graphs, and think about what makes them different. Okay, so hopefully you did that. We're looking at 5 different graphs here. We want to notice for these ones, for the red, orange, yellow, and green graphs, they all have the same y-intercept is the same. Which means that also the starting position is the same as well. Okay. The next thing we need to look at is the slope of these different lines. So we notice that that the red line has a very steep positive slope, whereas the orange line has a less steep positive slope. So that means they have different velocities. The simplest way to do that, since this has the greatest slope, is we would say that this one, the red one, has the greatest velocity, whereas the orange one has less velocity. Make that a little smaller. Okay, let's look at the yellow one now. Think about what the yellow one's slope is. So these guys had different velocity. The yellow one has a slope of 0. Because it's just horizontal. That means that it also has a velocity of 0. This is one of the ones that students get confused by the most. So this means that it starts at some positive position and it just stays there. Velocity is 0. What about the green one down here? Well, it starts in the same position as everybody else, but since its slope is negative, that means the velocity is also negative. Okay? And so that means it's moving the opposite direction of these other ones. It looks like it's about the same amount of velocity, about as steep as orange, but they're moving in opposite directions. The last one I want to show you is this purple one right here. The purple line starts at a different position from the other ones, and it also crosses the x-axis, which is always significant. We want to always think about what that means. In this case, it's pretty simple. Crossing the x-axis just means that you reached a position of 0. You reached the origin. So if we were to draw the motion diagram, this is your position of 0 meters. This purple object started on the positive side, moved in the negative direction, crossed the origin, and then moved onto the negative side, just like this. All right, so remember, we're always looking at the y-intercept because that tells us the starting position, and we're always looking at the slope because that tells us the amount and the direction of the velocity. All right, the next thing we need to be able to draw is velocity versus time graphs, and that's actually very simple. So when we draw a velocity versus time graph for constant velocity, the first and hardest thing to remember is that the velocity is constant. So if we're drawing a graph of constant velocity, let's say my velocity starts off as -4 meters per second. Well, at time 0, it's -4. 1 second later, still -4. 2 seconds later, still -4. 3 seconds later, still -4. So, since it's constant, this line is always going to be horizontal. It's always going to have a slope of 0 because the velocity doesn't change. So the only thing you have to pay attention to on these graphs is what the initial value was, because it's going to stay at that the whole time. Let's look at some examples. You got 5 graphs on here. Go ahead and pause the video and think about what those different graphs mean. Okay, let's do it really quickly. So notice all of the graphs are horizontal, meaning the velocity doesn't change. They're constant velocity. These two up here, they're both positive velocity the whole time because they're on the positive side of the y-axis. These two are both negative velocity. Remember that positive velocity and negative velocity tell you which direction the object's going. These are moving in the positive direction. These are moving in the negative direction. This one right here has 0 velocity because it's at 0. That means it's not moving, right? These are moving, that one's not.